Morning, Joe.
Morning. Morning, Miss Sharina.
Yeah.
Morning, Miss Sharina.
Morning.
Misha, some questions are deep, but some questions I don't know.
You will discuss today, na? We can discuss.
That's the same.
Okay, I'll quickly take attendance, yeah? Um, okay, Isaac. Okay, Isaac is here. Isabel. Isabel not here. Abigail.
Yeah.
You okay? Ah?
Yeah, sure.
Okay. Carlos. Carlos not here. Elijah. Hey, Elijah here?
Elijah's here, sure.
Why not responding? Ah?
I don't know.
Elijah, can you hear me?
Maybe he went toilet or something. Yeah.
Yeah.
Kavishka? Kavishka, are you here? Ricardo? Oh, okay. Ricardo?
Here, Chair.
Celeste? Okay. Pooja? Sureka?
Here, sure.
Wouldn't look. Not here. Zarit? Zarit not here. Michelle? Malcolm? Here. Jared?
Here, Chair.
Here, Chair.
Elijah? Are you here?
Here, Chair.
Isabel is not here. Okay, just give me a moment. Okay. Okay, before we start, let's just let's play a game lah, cause it's 9:12. Okay, anyone has any game suggestion? One suggestion I have is Pictionary lah, but do you all have any suggestion that we can all play online?
No, sir.
No.
We could all try downloading a game and then start playing on the computer.
What?
No.
We could play a computer game. Do you have Steam, Jeff?
It's okay. Okay, who wants to start?
Who wants to start?
Tic-tac-toe, Jeff.
Huh?
Tic-tac-toe.
Okay. Sorry, Ali, everyone can play. Yeah, start lah. Start drawing first, okay? So see who can.
Yes.
My drawing is not that great lah, but all the best. Yeah, try again. Okay. Can you all see?
Yeah.
Yeah.
Can I see?
A door. A living room. A doorway. A window.
Our classroom, sir.
No.
Is it a door and a window?
Yeah, I think I'm gonna draw the whole thing now.
TLC.
Huh?
TLC. Our school.
What, Kavishka? I heard Kavishka say something.
House.
Yes.
Oh.
Okay, who wants to try next? You can draw on the whiteboard.
Elijah, will you do the honor?
You can
Elijah, what do you do?
look around your house and then pick something and then draw.
Good.
Anyone wants to try?
How to draw?
Okay, you look at your are you on laptop or phone?
Laptop.
Okay, you go to the button that says more or the 3 dots on Zoom, and then there's something called annotate.
And okay.
And then now you can draw.
Okay.
Are you drawing? I don't see anything.
Are you drawing?
Yeah, sure.
Oh, okay. Now I see.
Oh.
Pancake ah? No, not pancake. Pizza.
Pizza?
Yes.
Okay.
What do we do with pizza?
Okay, next one to try.
I don't.
Huh?
Abigail, try.
No.
One more. One more person. Don't like play games one.
I like church. These people don't want to play. Then back, but
Okay, Ricardo, try. Pick something and draw.
Okay. What's happening? Okay. So damn, it's very hard to draw. I'm doing on phone. Sure, why is that two coming out? Sure. Oh, okay, never mind. Disappeared.
is it Ice Cube?
Bob.
Empty box. Oh, fridge.
Yeah.
Oh.
Okay, nice. Okay, let's start. Maybe after 15 minutes we'll come back to picture, okay?
Okay, sure.
So those who want to draw, you can start thinking of what you want to draw. Okay, let's look at this worksheet which was given to you. Okay, yeah, let's go through the questions. Okay, so figure 3.1 shows an oil tank that has a rectangular base of dimensions 2.4, 1.5, and then the depth is also 1.5, depth of the oil. The tank is filled with oil of density 850 kilograms per meter cube to a depth of 1.5. Calculate the pressure exerted by the oil on the base of the tank. So what formula do we use? How to calculate this? Hey, can you all hear me?
Yeah, density over weight, over force.
Density over force.
Yeah.
Asking for pressure. What is the formula for pressure?
So I will put using for height times density times gravitational.
Yeah, so they're asking for pressure exerted by the oil. Oil is liquid, right?
Yeah.
Pressure equals to, let me turn back to the whiteboard. Pressure H rho G. Rho is density of the liquid. So that's how we calculate pressure for liquid. So what is the height? Height is basically the depth of the oil. So what is it?
1.5.
1.5. What is the density?
850 grams per meter cube.
And then gravitational acceleration we can put as 10. So what do you get?
Which it's 10 or 60.
Why 16? Huh?
The gravitational thing, did you write that 10 or 60?
Why 16?
I don't know, it looks like it's a 60 or something. Oh, okay. So why 10? Huh?
10 is the standard constant for gravitational acceleration that has been measured now.
That means in everything is also 10. Right?
Yes, unless sometimes it's actually the actual value is 9.8 something, but they usually round it off to 10 now.
Oh, okay.
If they don't give you any value, that means it's 10. If they give you a specific value, then you use that value lah. Okay, so what is this? 1.5 times 850 times 10.
13,000.
12,750 psi.
Huh?
What the difference? 1.5 times 850 times 10. We have 12,750. Okay, so that is the pressure exerted by the oil on the base of the tank. Okay? Okay, what is the force exerted by the oil on the base of the tank? So we know that, what is a formula that has pressure in it and then also force?
Pressure equals force over area.
Right. So pressure equals to force over area. Now they're asking for force. So force will equals to pressure times area. The pressure has been calculated from before. What is the area? Look at the box below. Look at the tank.
1.5.
What is the area? How to calculate area of the base? Not 1.5. 1.5 is the length.
Sir,
How to calculate the area?
sir, is it 2.4 times 1.5?
The area of the rectangle. So area is 1.5 times 2.4. That's how you calculate the area of the base. That will be my area. So it is 12750 times, what is 1.5 times 2.4? Yeah, correct. 3.6. And then 3.6 times 12750. What do you get?
4,519 newtons.
45,900 meters. That will be my force. Can you understand so far?
Yeah.
Yep.
Anyone copying? Or can I shift back?
Sure, I'm copying, sure.
So after we do this, what are we going to do?
Sorry?
After we do this, what are we going to do?
Friends, I don't know how long this will take. Then I told you to do all the questions.
Yeah.
Okay. Let's see how it goes. Let's see how long it takes.
So you're not tired.
Huh?
You're not tired, Che.
Wait lah. You're tired, ah?
Yes.
My brain can't. My brain is not agreeing with my body.
What time you all slept last night?
4.
4.
But I told you not to sleep.
4 is a regular time, teacher. It's very long.
What do you do on football? Watch TV? Watch movie?
No, suddenly Thiel had some personal talk, all that. He was like asking was he studying and everything.
What?
Oh.
At 4 in the morning.
Yeah.
What were you doing at 4 in the morning?
Thielen, he was talking about his future.
Oh.
Yeah, so yeah.
Very nice.
So is it good to sleep at 4 o'clock and 5 o'clock?
No, Surika. What kind of question
No,
is
Sarika,
that?
you only have like
What
4
is
hours
it?
of sleep.
Yeah. Your body, there is a time where your body needs to rest in order for your new cells to grow. And I think that's like 3 to 5 in the morning. That's when I can't remember the actual time. Is it 3 to 5, 2 to 4? I can't remember. So that time is when your cells are repairing. So you must make sure that you're sleeping during that time.
Oh no, that's why I'm growing short.
Hey, really short.
That's why I'm taller than Sarika now.
I'm shorter than Kavishka.
How do you all know? You all not even seeing each other. What?
We can just predict.
Okay, let's look at B. The force calculated in A2, which is 45,900, is the weight of the oil. So what will the mass of the oil be?
So I got 4,781.25 kg.
How did you get that?
First, I found the density. They already gave the density. Therefore, I found the volume. And then the formula to find mass is mass times density times volume. No, mass equals density times volume.
Okay. Anyone got any other answers? Judith, what did you get? Judith, what did you get for that question? No answer. Judith is not here. Celeste, what did you get for B? No reply. So, Kavishka, what did you get for B? Hey, where are all your friends now?
Kavishka.
Kavishka left. So everyone on your video for a while. All those who don't have their video turned on your video for a while.
So I have very messy.
Never mind.
Or you.
For the hospital.
Just on, it's okay. No worry, I won't like penalize you for looking bad in the morning.
I literally woke up 10 minutes before class. That's something I'm getting very good at.
Okay, so I see Surekha, Abigail, Pooja, Elijah. Okay, I see Elijah. Isaac. Okay, I see Jared. Isaac, can you please on your video? Elijah is so muscular. Celeste? Isaac doesn't have camera.
Drugs or something like
Can I
that.
just
Just
see
overdosed on something.
Ricardo, can I see your face also? You all look the same, huh?
Yeah, sure.
Okay, I see Ricardo. Celeste? Malcolm, Kavishka. Isaac has no camera, okay. Okay, I see Malcolm, I see Kavishka. Celeste? Celeste not there. Okay, you all can turn off your videos now. Thank you. Okay. Let me share screen in. Okay, so the force calculated is the weight, calculate the mass of the oil. Now, one way to do it is what Elijah said, density is equals to mass over volume. Let me just erase this off. But there is a reason why they mentioned force as the weight and then they ask you to calculate the mass. Okay, so okay, so one way is like
Silika, are you on your bed?
density equals to mass over volume. My density was given as what just now in the question?
850 kg per meter cube.
My mass is what we want to find. What is the volume?
The volume is 5.625 meter cube.
So if you look at this, the volume will be 2.4 times 1.5 times 1.5. That is the volume.
5.625 meter cube.
Is we calculate 2.4 times 1.5 times 1.5 is 5.4, correct?
So can you repeat what you said? I couldn't hear you.
Yeah. Okay. So 2.4 times 1.5 times 1.5 is 5.4, correct?
So but I got 5.625.
Calculate again. You get 5.4.
Really? 1.5 times 1.5.
Then you
Wait,
break.
what? So I swear my calculator is a scam.
So 850 times 5.4. What's the mass? The mass?
So the answer 4,590 kg.
590 kg. Okay, but let me tell you another thing. So if you look at the question, okay, it says that force, they mentioned here, force calculated is the weight. That means right now, what is the force that we calculated from the previous question?
45,900 newtons.
They're saying that this is the weight. And then they say from the weight, what is the mass? And if you remember last week, now, what causes the weight of an object?
Mass.
No, a mass, yes.
Gravity.
Gravity causes the weight. That's why you have weight. Okay, that means your mass, let's say you are 50 kg here. Okay, when let's say you go to the moon, your mass will still be 50 kg, but your weight will be different. Why? Because weight is affected by gravity. In
Teacher,
weight,
can't you just add another zero because it's times 10? The weight to the mass.
sorry?
Can't you just times 10 to the weight?
So, yes, which is what I'm going to mention now. So in
Uh.
the moon, the gravity will be different. So depending on the whatever the gravitational acceleration is there, and then you will get a different weight. So now the gravitational acceleration on Earth is how much?
10 newtons.
10.
10 meter per second, okay, because of gravitational acceleration. So from mass, from weight to get mass, I just take 45,900 divided by 10. So it's 4,590 kg. That will be your mass. Okay, so from weight to come to mass, you divide by 10. You divide by the gravitational acceleration. Why divided by gravitational acceleration? Why divided by 10? Can anyone tell me? Why do we divide by 10? Why divide by 10? Why from weight to come to mass, why must we divide 10? What does 10 signify? What does 10 signify? You guys simply put the number 10 here.
4,590.
Yeah, but why 10? Why do I divide by 10?
Because 1 kg is 10. No, wait.
Is it
1
because
kg is 10 newtons.
No, what does 10 signify?
gravitation force?
Gravitational acceleration.
Wait, what? So what does gravitational acceleration mean?
Gravitational acceleration is basically okay. So gravitational acceleration is basically a value that is given in conjunction with the pull of gravity to the center of the Earth. Okay, so on different planets there is different gravitational force. Okay, on Mars, on Jupiter, on the Moon, on Earth, they all have different gravity, like different strength of gravity. In other words, okay. So gravitational acceleration is a value that is given to an object when there is no air resistance, okay, theoretically. So when for different planets, they have different amount of air, they have different forces acting in the atmosphere and all these things. So gravitational acceleration is basically, in simple terms, is the pull of an object to the center of the Earth, because center of the Earth is where gravity is found. So gravitational acceleration is that value essentially.
That means if you go to the center of the earth, you'd immediately be crushed to atoms, right? Because of the gravity there.
Yeah, probably, maybe. So we divide it by 10 because that is the gravitational acceleration. Weight has to do with gravitational acceleration. So I divide by 10. Why? Because weight is affected by gravity. Why we have weight is because of the gravitational pull that pulls us down to the center of the Earth. To get mass, I just divide it by 10 and I get 4,590, which is the same if I use this method lah. But why I using this method? Because the question mentioned the weight, and then they asked for mass. So for weight to come to mass, it's 4,590. Okay? Can everyone okay? Okay or not?
Yeah.
Yeah.
Okay, so let's look at the last part of this question. When he's checking the level of oil in the tank, a man drops a brass key into the oil and it sinks to the bottom. So the brass key sinks to the bottom. What does this show about the density of the brass?
It is higher than oil.
Correct. So the density of brass is higher than the density of oil. So which one is denser will be the one that sinks. So in this case,
The brass key.
sinks into the bottom, which means its density is higher than the density of the oil. If it floats in the oil, that means oil is denser than the key's density. Understand? Ken?
Yeah.
Yeah, sure.
Okay, now explain how attaching the key to a piece of wood could prevent the key from sinking. How is it that by attaching the key to a piece of wood, it could prevent the key from sinking?
Yeah, I wrote the key's density is higher than the wood, but the wood is heavier. The density of the wood is lower than the water. Because of this, the wood floats while preventing the key from sinking because it has a greater mass than the key.
Okay. Okay. Anyone else?
Sure, I wrote the density of the piece of wood is lesser than the oil, so it will float.
The density of the wood is what? Can you please repeat that?
The density of the wood is lesser than the oil, so than the oil's density, so it would float.
Okay. Anyone else? Anyone else? Why attaching the key to a piece of wood could prevent the key from sinking?
So I put the wood density is lower, so it makes the key rest float.
Okay, so similar to Jared's answer. Ricardo, what did you put? Is Ricardo here? No, not here. Sureka, what did you put?
I put the key is less denser than the oil. The same too.
Okay. Anyone else got any other answer or not? No.
Yeah, I have a question here.
Yes.
Yeah, at around 10:15, can we have like a 20-minute nap time?
Lap time, nap time.
Yeah,
What?
please lah.
Yeah, y'all got class after this?
Yeah, check English for 2 hours.
Yeah.
2 hours. English for 2 hours.
Okay, come. We'll take a short break after this. Now, how attaching the key to a piece of wood could prevent the key from sinking. Okay, so now on the piece of wood, right? So in this case, the density of the wood is going to be lesser than the oil for it to float, correct? Before that, Elijah, now you mentioned something about water, denser than water. What do you mean by water? Oh, can you read your answer again? Okay, everyone listen,
Me, who, what?
read your answer.
Me, ah? Okay. The key's density is higher than the wood, but the wood is heavier. The density of the wood is lower than the water. Because of this, the wood floats while preventing the key from sinking because it has a greater mass than the key.
Greater mass than the key. But greater mass would equal to greater density, what?
No, sir, but if you must take in wait, the volume also has a role to play in it, sir. So you need both of those things to be high, but because the thing is flat, right, sir, the the upthrust equals to the downward force. So the wood floats, but then since the key is being tied to it, it doesn't completely sink. Because the wood is technically heavier, so it can pull it up. It has more, in a way to say it has more force, lah, but not exactly.
Okay, so now, but the thing is, right, we don't know this question, we don't know whether the wood has a bigger mass or the wood has a bigger volume, or we don't know. So how do we come up with an answer without assuming those things?
Okay, please just say it's correct, lah. I can't function anymore.
Yeah. Okay, so now a piece of wood, right? What wood would have is buoyancy. Okay, so buoyancy is basically a force that pushes something upwards in liquid. Okay, so when buoyancy comes to play, this piece of wood, the buoyancy will push the wood upwards. Okay, which will help the key to float because the key is attached to the piece of wood. Okay, so what you can say is the piece of wood experiences buoyancy, which helps the wood to float. Can I understand?
Yeah.
Could you write that down again?
Gotcha.
Sure, is there like a formula for buoyancy or something?
Formula for buoyancy. There's no formula. There's a formula related to buoyancy lah.
Sure, but what unit is buoyancy counted in?
The force, so Newton.
Okay, sure.
Okay, we all can take a quick break. Come back at 10 o'clock. We have 10 minutes break, okay?
Oh, thank you, lecturer.
Okay, come back at 10.
So can you give me 5 minutes?
Okay, go. The rest of us will play Pictionary. Okay, anyone wants to draw? Oh, no. Oh, someone's drawing. Okay, draw. Drawing, draw. Okay. Can I know who's drawing just so that I know? I mean, yeah. Who's drawing, huh?
Sure, my fingers slipped by accident.
Huh?
My fingers slipped. I was on the painting and I wanted to go back to my own camera.
Oh, okay. Okay, let's see. Kavishka, try.
Okay.
Next, Malcolm, Malcolm, get ready. Think of something. Table, lah.
Yes.
Okay.
Yes.
Okay, Malcolm? Okay.
Laptop.
Is it correct, Malcolm?
Yes.
Okay. Okay, good job. Okay, one more. Let's see. Isaac, can you draw? Do you have the pen feature? It's under at Zoom. It's under the. You go look for the 3 dots or the word more. No, you can draw anything. It doesn't have to be a specific thing. Yeah, it can be anything.
Beta.
Yes, it's a bid. Okay. Anyone else want to try before we continue? No? Okay, then let's continue. Okay. Okay, let's look at this. A student wishes to find the volume of a piece of wood of an irregular shape. Her experiment requires the use of a small brass object of mass 200 gram. Calculate the volume of the object and given the density is 8.4. So how to calculate? How to calculate, guys? You're given the density and you're given the mass. So what's the volume?
Okay, I'm back.
Sorry?
I'm back. What question are we doing now, Jen?
2A.
So my answer for 2A was 23.8 cm cube.
3.8.
No, wait, it's
Same, Chair.
3.81 cm cube.
Density equals to mass over volume. What is the density given?
The density is 8.4 grams per cm cube.
Yeah. The mass is 200. Want to find the volume. The volume is equals to, bring this to the top and bring this to the bottom. 100 divide 8.4. What is 200 divide 8.4?
23.81 cm cube.
Yeah. So it's just 3.81 cm.
Chair, but I wrote 23.8 cm cube only.
Okay, let's continue. Okay, to find the volume of the piece of wood, the student has a measuring cylinder, a supply of water, and the object in A. The piece of wood and the object are small enough to be placed in the measuring cylinder. The piece of wood does not sink in the water. Why?
Its density is lower than the density of water.
So the density of the wood is lesser than the density of water. So it does not sink. Huh? Okay, what does the student do to find the volume of piece of wood, stating the measurements that she makes and calculations required? So how
Can I
to
say, Joe?
how to find the volume of the wood given the water, the measuring cylinder, and all that? Okay, Elijah.
I wrote first the student should fill a measuring cylinder with water to a selected volume that would be right for the experiment. Then he should place the piece of wood inside and observe the depth increase. After this, he should find the difference between the original depth and the new depth. This difference is the volume.
Correct. Very good. So that is basically how you. Can you all see the questions on the board? On the what? Can you all see these questions on my screen?
Yes, yes.
Can, Chair.
Okay, so what Elijah said was right. So basically what happens is I have a measuring cylinder. Okay. I have a measuring cylinder. And then what happens is I fill it with water first. Okay? Fill it with water first. And then I mark what his reading is. So this is the initial volume, the original volume. And then I drop the piece of wood in. And then, of course, the water will increase, the water level will increase. So let's say it increases to, after with the block, let's say it increases to here. So this is my final volume. Then to calculate what is the volume of the block, I take my final volume minus my initial volume. That will give me the volume of the block, of the wood. Okay, can I understand?
So you don't they ask questions like this like 3 times?
Yeah, they do. I mean, this is just practice one, so that you get the hang of it now. But they won't ask 3 times, like exam, I won't ask you 3 times. Okay? Okay, all okay so far? Yes? Okay. A student has 500 identical rectangular sheets of paper. The mass of 1 meter square of the paper is 0.08 kg. Using a meter rule, she measures the length of 1 sheet of paper and its width. The length is 0.3, the width is 0.21. What is the mass of 1 sheet of paper? How to do?
Sorry, Joe?
How to do 3A1?
I did the length times width, so 0.300 meters times 0.210. So I got 0.063 meters square.
Okay. That is the area, right?
Yeah.
Okay, so what is the mass of 1 sheet of paper?
Yeah, for the mass, I don't know what to put, so I just where to put the area there.
Okay, let's look at it together. Anyone know how to do?
Not sure. This from here only I got confused.
Okay, anyone else? Abigail, can you? Did you manage to do?
Yeah, I didn't do this one. Yeah. I don't understand.
Ricardo?
I didn't know how to do from this point.
Celeste? No, okay. So it says here they have 500 sheets of paper and the mass of 1 meter square of the paper is 0.08. Let me just write it down. Okay. Now let's look at this together. Okay, so 1 sheet of paper is 0.3 times 0.210. Okay, and then it says 1 meter square is 0.08. Okay, now for this 1 sheet of paper, what is the area? What is the area of this 1 sheet of paper? How to calculate area? Abigail, how to calculate area of rectangle? If I have a rectangle, how to calculate area?
0.2 times 0.200.
Sorry?
0.2 times 0.300.
Okay, so I times both of them together, length times width. So 0.3 times 0.210. I get 0.063. So this is the area of one sheet of paper. So see here, he's given 1 meter square is 0.08. Now they're asking for the mass of, so they say that the mass of 1 meter square sheet of paper is 0.08. Now I want the mass of one sheet of paper. The mass of one sheet of paper has an area of 0.063. So 1 meter square is 0.08. 0.063 meters square is how many kg?
$15.87301587.
Sorry?
15.87301587.
How you calculate? How you get that?
1 divided by 0.063.
1 divided by 0.063. 1 meter square is 0.08 kg. 0.063 meters square, how many kg? This ratio. It's like 1 apple is 0.08 kg.
I got 1.1.269841127.
No. 1 apple is 0.08 kg. If it's 0.063 apples means how many kg? Again, huh? Okay, 1 meter square is 0.08 kg. 1 meter square, what do I do? One block is 20 kg. 2 blocks?
40.
40 kg. So 1 meter square is 0.08. 2 meter square?
0. 0.16.
0.16, yes. So 1 meter square is 0.08. If it's half meter square means, if 0.5 means, how would it be? Hmm? 1 meter square is 0.08. If it's half meter square means, do you all understand what I'm saying or you all are lost?
0.04.
I don't understand, sir.
1 meter square is 0.08.
Okay.
Half meter square means half of this now. Half times 0.08 or 0.08.
Yeah.
So if it's 0.063 means, half of 0.08 is 0.04. That means half times this now.
Okay.
So if 0.063 of 0.08 means, I just times it. So what is 0.063 times 0.08?
5.04.
0.063 times 0.08. In your calculator, you will get
0.00504.
5.04 times 10 to the power of -3. Or you will get 0.00504. Correct? Do you all get this?
Yeah.
So 0.063 meters square will equal to 0.00504 kg. It means one sheet of paper which has the area of 0.063 meters square will have this mass. So that is the mass of one sheet of paper. That's what the question is asking. Understand now?
Yeah.
Yeah.
You know 1 meter square how many kg? So now they're asking you for one sheet of paper which has this area, what is the mass? So you use ratio lah. Okay, I'll give you all some time to copy it down. Anyone confused? Can I understand?
Yeah, cha.
Yes, sure.
Okay. Okay, let's look at this one question and then since we're a bit down, we will do something else, okay? Okay, let's just look at this last question. A second student has only 5 sheets of the same type of paper. Suggest how the student determines the density of the paper to a similar accuracy. Additional apparatus may be used. So second student only has 5 sheets of paper. How will the student determine the density?
So this one
Sure.
I didn't answer, Jeff.
Sure.
Yeah, yeah.
She's able to use a micrometer, right?
Okay, yeah, can.
And measure the thickness of the papers, right?
Can, yeah. Correct, that's one way. Elijah, you had something to say?
No, I'll just say I do not know how to do this question.
Okay, yeah. I'll show you all.
What's a micrometer?
I'll show you all. Wait, you all can see me googling?
Is it in the textbook?
It might not be, but let me show you. So this is a micrometer. So it measures the thickness of the paper. Okay. Using this, because density is mass over volume, we already have the mass of one sheet of paper. In order to find the density, we need the volume. To find the volume, we need length times breadth times width. So for the width, length times breadth times width. The thickness will give me one dimension to find volume. So we use this, which is a micrometer, and this helps to measure the thickness of the paper. So using this, we measure the height the other dimension, and then using the area, which is 0.063 times with the dimension that we can get from the micrometer, and that will give me the volume. And then mass divide volume, I will get the density. Can you understand? So basically, I have for density, I need mass, which we already have, over volume. Okay, mass was 0.00504 kg. Now for volume, I need this, and I need the thickness of the paper. The paper is very, very hot. So what we use is we use a micrometer. So using a micrometer, you can calculate you can measure the thickness of the paper. Okay, and then to find volume, it will be 0.3 times 0.210, which is 0.063, times with the thickness of the paper. Thickness, I'm going to put T, and that will give me the density.
So you're doing 3A2 now.
The second part, yeah,
Okay.
this part. 3B. Oh, I haven't done 2, Okay, never mind. Look at B first. Yeah, so that is how they calculate the density.
I just wrote she could use a micrometer.
Sorry?
I just only wrote she can use a micrometer. Je.
To explain, using micrometer, measure the thickness of the paper, and then that value is multiplied with the area, that will be the volume of the paper. And then I take the mass, divide by the volume to get the density. Okay? Okay, let's look at 2. The student makes a single pile of the 500 sheets of paper. With a meter ruler, she measures the height of the pile. The height of the pile is 0.048. What is the density of the paper? So how to calculate? This is also similar. Density equals to mass over volume. Mass of the 500 sheets of paper is
Sure, to measure the volume, we can use 0.300 times 0.210 times 0.048, right?
Right. That is for the height of the, for the volume of the paper. For the mass, you can take, so 1 meter square is, so you take like this, switch to the board. Okay. So again, density is mass over volume. Now it says that the height is, so she has arranged it in such a way that she has stacked it up. So the height is said to be 0. What?
0.048.
0.048. Not 0.48. 0.048, okay? And then the base will stay the same as 0.3 and 0.2. So density is equal to mass over volume. Volume is this times this times this. So now my mass. So I know that 1 paper, which is equals to 0.063 meters square. What was the mass just now? 0.0500504. Correct? From the previous question. 1 sheet of paper, which is 0.063 meters square, we calculated just now, is 0.00504 kg. Am I right?
Yeah.
Yeah.
1 paper is this. 500 papers will be, I times up, because 1 paper is this kg. So 500 papers will be 500 times 0.00504, which is,
2.52.
let me double check. 2.52 kg. So 500 sheets of paper is 2.52 kg. So the mass of the 500 pieces of paper is 2.52 divided by the volume. What do you all get for density? 2.52 divide this.
Zero point zero 0.084672.
Okay. I got something else. Let me try again.
So I got 83.34.
I got something else. I got 833.33.
Same, sir.
Does anyone else get a different answer? Abigail, try again.
Okay, sure. Now I got 833.33.
833.33 kilogram per meter cube. Because it's divided. Do you all get this?
Yeah.
So this is one sheet of paper is this mass. So 500 would be 500 times that, which is 2.52. That is the mass of the 500 sheets of paper with the volume. Volume is the base area times the height. Okay, everyone can follow? Ricardo can follow?
Sure, will the questions be this hard for the exam?
Hey, this is okay one. Not hard one. You just need to dissect the problem properly now.
Just a little bit confusing, sir.
Need to dissect the question. It's like drawing always helps, especially when it comes to maths. Like in this case, it's a maths question one. Must always draw. Only when you draw, you can visualize it. Okay. You all seem a bit demotivated today. Are y'all okay? Are y'all demotivated?
Okay, sir.
Are y'all like going out or did something happen?
No, sir.
No, sure.
You want to broke up? Huh? No.
No.
God love only go can break up, right, sir? Don't tell me so.
No, sure.
What? What's that?
There are no one to break up with.
No, what? I